Hey, welcome back. Last time we talked about the basics of for loops, and now we're going to take those basics and apply them to our bike share simulation. Um, Remember, we now have two things that we need to bring in here. We need to bring in first that step of P1, P2 simulates 1 minute of the simulation of the bike share model. Where P1 is the probability that a bike goes from Olin to Wellesley, P2 is the probability a bike goes from Wellesley to Olin, and we need to bring in that a for loop can run uh, a set of commands multiple times. All right, so we're going to set this up and we say, okay, if we want to simulate our bike share simulation for 1 full hour, then what we'll do is we'll use maybe for I in range. All right, so this was step does 1 minute, and since we want a full hour, we'll do a range of 60. So this takes this for loop is going to happen 60 times from 0 up to 59. And what do we want it to do? Well, we want it to apply this step function, and we'll have it apply it with the correct probabilities. So we don't know what the correct probabilities are, but we could just use those probabilities we had earlier, and maybe we'll change those based on what we see. All right, and so what this code here is doing is it's running for I in range 60. So I goes from 0 to 59, and it does this for every I. Now you can see here that this step here, the code in the code block, it doesn't depend on I. So we're really using I just as a counter. So I is just a counter. If there were some aspect of this step that depended on I, so if the probabilities that a bike is taken changes and depends on I, then you could maybe write these as functions of I, 0.5 and 0.33 as functions of I, and then it would depend on I. But at this moment, what we're just doing is we're just using I to represent the time from 0 to 59. All right, so when we run that, then we get we are simulating 60 minutes of time, so a full hour. Let's head over and let's see this in action. All right, so we're in the next section of the for loop here. So we are using, here we redefine the step function to not have the print statements in it, especially if we're going to do for 100 minutes or 1,000 minutes. You probably don't want to see every time the bike goes back and forth. So that's the only change to the step function here. We'll reset the value of bike share. If we don't do this, then we're using whatever bike share was defined in the computer to be before. And so, for example, here is a for loop that uses range 4. So this is a bike share where 4 bikes are sent to Wellesley. So that's just an example of using the for loop to do that. Or we could simulate 4 different time steps. We could simulate a different probabilities, 0.3 and 0.2, instead of 0.5 and 0.33. we run that bike share. So we don't know if there are any bikes that moved, but we do know that the end result is the same. But let's now go back and reset our bike share. So we reset and set our bike share. Put in a code block above here. Put our bike share back in. Reset the bike share, and we can check to make sure it's the correct thing. Here we are. Olin has 10 bikes, Wellesley has 2. And now if we run the code, we can see that after 60 minutes, there's still 9 bikes at Olin and 3 bikes at Wellesley. Let's run it again. Let's reset and run it a second time. Uh-oh. This time, there's now -1 bikes at Olin and 13 bikes at Wellesley. We're going to have to fix that. But you can see now, in this instance, a net 11 bikes moved from Olin to Wellesley. Let's run it again. This time, after an hour, there's 7 bikes at Olin, 5 bikes at Wellesley. This is really making you want to look under the hood and see what's happening over time, right? And not just to know what's happening at the ends, but what's happening during that hour. How many bikes are moving? What's happening? Is it staying mostly constant, or is it really fluctuating a lot? And so what we're going to do is we're going to collect that information as the for loop is running. So let's go over and talk about that. What we're going to do is we're going to use this a new object called a time series. All right, so let's talk about a time series. All right, so we'd like to run our bike share simulation multiple times, and we'd like to keep track of what's happening. So a time series object is a way to keep track of data. And as one of the homework assignments, I want you to go in and read what the book says about the time series. So take a look at how this time series works and see if you can understand its structure. And we'll talk about it more in class. Okay, so here's how we're going to set this up. So one of the questions somebody had in class is, can we put a whole bunch of code in the same block? And this is what we're going to start to do. As we build our code and as we build our simulation, we're kind of going to want to have more and more things in the same block of code because we want them to happen one after the other. So the first thing we want to do is we want to reset our bike share. So we have bike share is equal to the state is equal to a state object that has Olin equals 10 in it and Wellesley equals 2 in it. All right, and now we're going to define an empty container. We're going to define results equals time series. All right, so this first line of code, this resets bike share. And this second set of code, this creates an empty container. Creates an empty time series object. And then what we're going to do is we're going to start putting information into this, one piece of information for every time. So we're going to first initialize it and define results of 0 to be equal to bikeshare.olin. Okay, so we've created our empty time series object, and now we start to fill in. So we want to add in information and in this case what we're adding in is how many bikes are initially at Olin. Okay, so this is basically time is equal to 0. So at time equals 0, how many bikes are there at Olin? Okay, and now what we want to do is as we run our simulation, so these are our pieces that initialize our setup. And now what our goal is, we're going to run the simulation for 10 steps. All right, and remember to run a simulation for multiple steps, we use a for loop. For I in range of 10, right? Then we put colon. We're going to do the step, 0.3, comma, 0.2. So this is run one time step. And then collect the data. Okay, and so I'm going to write this results. So I'm going to put some information into results. And I'm going to have it be equal to bikeshare.olin. Okay, so let's think about what we have to put in here. We're going to put something in here based on I. So let's think about, remember the range 10 looks like this. It looks like 0, 1, 2, up to 9. And so what we want, what step does, step, I like to think of it as going from time 0 to time 1, and or from time 1 to time 2, time 2 to time 3. This step is saying what's happening from the current time to the next time. So when I is equal to 0 and we run step, what we've done is we've said what happened to go from time 0 to time 1. So in this loop, I is still 0, but the results here correspond to what we're dealing with when we're at time 1 instead of time 0. So this results is results of I plus 1, because when I is 0 in the loop, then the results are the value of how many bikes there are at time 1. When I is equal to 1, then we run the step and we plug in the information about what the results are at time 2. So this I plus 1 is here because the step goes to the next time value, and we need to record the number of bikes there are at Olin at that next time value. So this code is going to put in the information at time t equals 1, t equals 2, t equals 3, up to, well, up to when I is equal to 9. When I is equal to 9, we plug in and we get results of 10. So this goes from t goes from 1 up to 10. And so in the end, we're going to have results of 0, that was our initial value, results of 1, that's our first piece of data that's collected, and we keep going up to results of 10. And so results is going to be a time series that has that information in it. All right, so we're going to quickly go and look at that. the last thing I want to say, and we're going to see this also in action, is there's a super easy way to visualize the data. And that, for me, that's always the treat. So then we can visualize the data with the plot command. And we do plot of results. And that's going to show us a visualization of the data. And there is a command defined in ModSim, in our ModSim package, that labels the axes. And that's decorate. And so we'll see, so use decorate before plot to label your plot. All right, let's go see that in action. Head over here. All right, so here's what we're doing. Results is equal to time series. So we create our base time series. We put in, actually we forgot to reset our bike share. So let's go back and reset our bike share. New code, reset our bike share. Let's reset our bike share. Let's figure out, let's see what our result, we create an empty results container. We plug in our first piece of data. Results 0 is equal to how many bikes there are at Olin, and just as we would expect, there are 10 bikes at Olin at time 0. And then if we run it for 10 steps and keep track of the results, then we have data for how many bikes there are at time 0, time 1, time 2, up to time 10. So let's do this again, but in one cell instead of a whole bunch of different cells. So let's create a piece of code here. We're going to first create our bike share object. Then we're going to create our results, our time series. And then we're going to initialize our time series with the information at time 0. And then we're going to run our for loop for 10 minutes. And then lastly, see what the results are of this. Right, so 10, 10, 9, 9, 9, 9, 9, 8, 8, 8. Run it again. 10, 9, 8, 9, 9, 9, 8, 9, 9, 10. And so this is a useful thing. We can get some data from it. We can get the mean of the values. And here's some statistics, so values that you can get to. And last, we can use plot to see a visualization of what happens over time, which is super nice. Of course, I'm looking at this and I'm thinking, let's do it again. Let's run it again. So because we put this all into one container, let me just bring this down. Because we put it into one container, we can just put everything into one cell and run that one cell. Boom, 10 up to 11. Let's run it again. 10 up to 11. Ooh, this one went down to 7. And then in my brain I'm thinking, well, why are we stopping after 10 minutes? What if we went to 100 minutes? What would that look like? Whoa! Run it again. Run it again. Because it's a computer, you can keep running this simulation over and over again and see what different days look like for the bike share. All right, so that's the end of chapter 2. Isn't this amazing? What we've done is we've modeled a whole bike share from start to end. We now have a situation where we have 10 bikes at Oldham, 2 bikes at Wellesley, and we've modeled 60 minutes worth of bikes moving back and forth. We're going to kick it up a notch in the next chapter, but I think we can be pretty happy with what we have so far. All right. See you next time. Bye.